The membrane has a property in which it is a semi-permeable or selectively permeable type of a membrane. The cell membrane has an inherent property of being semi-permeable or selectively permeable, so that it can allow various substances to pass in and out of it. This we are going to term as membrane transport. Now, based on the mechanisms, the transport is broadly classified into two types. The first one is based on the direction and concentration gradient. These are active transport, passive transport, and a third type is the vesicular transport, right. So, these occur based on the concentration gradient of the ions and they occur in a specific direction. And whenever there is a carrier molecule involved in order to transport the ions, it can be either carrier mediated or non-carrier mediated, right. It is easy to understand, either the carrier molecule is present or absent. Now, all of these type of transports, some of them require energy while some of them do not require energy, and we all know energy comes from the universal energy currency of the cell, that is nothing but the ATP. So, the ones which require energy is termed as active transport and those that do not require energy are termed as passive transport. Okay. This is how it is broadly classified. Now, we will concentrate mainly upon passive transport. It is broadly divided into diffusion and osmosis. Passive transport is of two main types, diffusion and osmosis. However, this diffusion can be simple, that is without the use of any other molecule, or it can be a facilitated type of diffusion, right, in which the diffusion of a large water soluble molecule occurs along with a carrier protein, right. So, facilitated diffusion requires carrier protein, whereas simple diffusion does not require any carrier proteins, right. So, simple diffusion basically occurs following a concentration gradient only, right, from higher concentration to lower concentration. Okay. Now, let us look at the image, then you will be able to understand. Okay. This is your lipid bilayer, that is nothing but your cell membrane, and these are the ions which are going to transport. Now, you can see that the concentration of these blue ions is more on this side. So, according to concentration gradient, they will diffuse along this side, right. This we are going to call as simple diffusion, right. Now, let us look at facilitated diffusion. Here you can see that although there is no ATP required, there is a carrier protein that is helping in carrying the ions from one side to another. So, this is called facilitated diffusion. Okay. Now, let us look at the mechanism of passive transport. So, we have seen that it is a transport along the direction of concentration gradient. This you can also call as a downhill movement of the ions, right. It does not require any energy, we also know that. See, there is a higher concentration here and then the ions are moving towards the lower concentration. This we are terming as a downhill movement. It is a passive process, that means it requires no energy, that is obvious, and it depends only on physical factors such as the concentration of the ions, the pressure as well as the electrical gradient. These are a few properties of passive diffusion. Now, there are a few factors which influence the rate of diffusion across the cell membrane. Right? Let us understand what are the factors which determine the rate of diffusion. So, the factors which are directly proportional, that means if the concentration gradient is more, then the diffusion is also more, right. That means if this is my cell membrane, there is a lot of molecules over here, ions, and nothing over here, that means the concentration gradient is more. So, there is more probability and more rate of passive diffusion that can occur. And the substance lipid solubility is very important, because we know that the membrane has a lipid bilayer, right. So, if it is easily soluble in the lipid, it will easily pass through it. So, more the solubility, more is the diffusion. Also, one more thing, important point, the cross sectional area, when you increase this area, see if I increase the size of this membrane like this, obviously the amount of diffusion will increase. So, these are the three factors which are directly proportional to the rate of diffusion. Number one, your concentration gradient, second is the substance's lipid solubility, and third is the cross sectional area of the membrane, right. Then number 3. Now, factors which are inversely proportional, that is the charge of the diffusing particle, the size, that means larger the size, lesser the possibility of diffusion, right, easy to understand. Because it is large, it cannot pass through easily. And one more factor that you can just guess is the thickness of the diffusion membrane. If the membrane is too thick, it is very obvious that it is not permeable to too many ions. So, these are the three factors which are inversely proportional: charge of the particle, size of the diffusing particle, and the thickness of the membrane. Now, simple diffusion is favored by, depending on these factors which we have learned, we can easily understand smaller size will be favorable, right, more lipid solubility is favorable, non-polar and neutrally charged substances will not face any hindrance while passing through the membrane, and the membrane itself should be thin with a large surface area, right. Small size of the particle, these are the properties of the diffusing particle. What is it? The size, solubility, lipid solubility, and charge, mostly neutral or non-polar. Of course, the membrane should be thin and of large surface area. Now, there is a law which governs the diffusion. This is called the Fick's law of diffusion. It describes the rate of diffusion along the concentration gradient. What is the rate of the diffusion? And this is given by this formula. You don't really have to memorize this formula, okay. However, let us just understand what it means. Here the minus sign, this one, indicates the direction of diffusion, okay, and D, capital D, this one is the diffusion coefficient, A is the area of diffusion membrane, and dC by dx is the concentration gradient, okay. This is the rate of diffusion. Now, let us look at a few differentiating points that will help us quickly revise as well as compare the different types of passive processes. So, there are three types: simple, facilitated, and osmosis as well. Now, simple, we know it occurs from high to lower concentration. Osmosis, on the other hand, requires sodium and water. An important concept that you have to understand over here is that if this is the cell and if sodium goes inside, it is invariably followed by water, and vice versa. If sodium comes outside, water will also come outside, okay. That is the principle of osmosis. Facilitated diffusion, we have seen that it requires a carrier protein. Coming to the example of simple diffusion is the diffusion of oxygen and carbon dioxide in the lungs, okay, and it follows the Fick's law. We have just seen what the Fick's law is, right. So, that is the example of simple diffusion. Now, because sodium is always followed by water in osmosis, it is termed as an osmotically active solute, and the concentration is given by milliosmoles, right. And facilitated diffusion obviously does not require any ATP, and the important example is the GLUT transporter and the aquaporin that helps in water transport. GLUT helps in glucose transport and aquaporin helps in water transport. Now, I have just uttered the word milliosmoles, right. So, let us quickly understand what is the concept of osmolarity and osmolality. Now, by definition, osmolarity is the number of milliosmoles of the osmotically active substance, for example, let's say sodium. So, number of milliosmoles of sodium that is present in a given liter of solute, that is osmolarity, is nothing but the number of milliosmoles of the osmotically active substance per liter. And the plasma osmolarity is 280 to 300 milliosmoles per liter. Kindly memorize this value, 280 to 300 milliosmoles per liter. Now, another concept, osmolality, is also number of milliosmoles of the solute, but per kg, not liter, right? Osmolarity is liter, osmolality is for kg of solvent. And the formula, few times this calculation can be asked. So, you will be given sodium ion concentration, glucose concentration and blood urea nitrogen as well. You have to multiply those values like so, 2 into sodium concentration, 0.05 into glucose concentration and 0.36 into blood urea nitrogen concentration, and add up all of that, you will get the answer as the osmolarity.